Hello everyone. In the last class, we introduced transformers and their application in power systems and the working principles of transformers. Today, we will talk about the classification of transformers and the nameplate data of transformers. To meet different usage purposes and working conditions, transformers have gradually developed into various types, and different types of transformers have significant differences in structure and performance. Transformers have various classification methods. According to their uses, transformers can be classified into power transformers, special transformers, and instrument transformers. Among them, power transformers are classified according to the requirements of transmission and distribution into setup transformers, which raise the transmission voltage, step-down transformers, which lower the transmission voltage, distribution transformers, which reduce the voltage to the level required by the users, tie transformers, which connect several different voltage levels in power systems, and plant transformers, which are used for the power plant's own electricity consumption. Special transformers, according to the specific requirements of metallurgy, mining, chemical and transportation industries, are designed and manufactured to meet specific requirements in industrial production. Examples include voltage regulators, rectifier transformers, etc. Instrument transformers are used for measurement purposes and include current transformers for measuring large currents and voltage transformers for measuring high voltages. According to the number of phases, transformers can be classified into single-phase transformers, which have primary and secondary windings for single-phase power, with the primary winding connected to a single-phase power source. Three-phase transformers, which have primary and secondary windings for three-phase power, with the primary winding connected to a three-phase power source. Multi-phase transformers, which have primary and secondary windings for multi-phase power, such as six-phase rectifier transformers. According to the form of the windings, transformers can be classified into double-winding transformers, which have high voltage and low voltage windings on the iron core. Three-winding transformers, which have high voltage, medium voltage, and low voltage windings on the iron core. Multi-winding transformers, which have more than three windings on the iron core. Auto transformers, which have electrically connected primary and secondary windings. It is worth noting that the most commonly used transformers in power systems are double-winding transformers, followed by three-winding transformers and auto transformers. According to the iron core structure, transformers can be classified into core-type transformers and shell-type transformers. In core-type transformers, the windings surround the iron core, while in shell-type transformers, the iron core surrounds the winding. According to the voltage regulation method, transformers can be classified into no-load voltage regulation transformers and load voltage regulation transformers. According to the cooling medium and cooling method, transformers can be classified into dry-type transformers and oil-immersed transformers. Dry-type transformers rely on air for cooling, while oil-immersed transformers rely on transformer oil for cooling. Oil-immersed power transformers can be further classified into three cooling methods: self-cooling, forced air cooling, and forced oil circulation cooling. Self-cooling relies on natural convection of oil. In forced air cooling, fans are added to the self-cooling system to blow air on the oil tank walls and oil pipes for cooling. In forced oil circulation cooling, oil pumps are used to draw hot oil out of the transformer, cool it in a cooler, and then return it to the transformer. The cooler can use circulating water cooling or forced air cooling. According to capacity, transformers can be classified into three types: small and medium-sized, large and extra-large transformers. Small and medium-sized transformers have a capacity of 10 to 6,300 kilovolts ampere. Large transformers have a capacity of 8,000 to 63,000 kilovolts amperes, and extra-large transformers have a capacity of over 90,000 kilovolts ampere. Next, we will talk about the nameplate data of transformers. Every transformer has a nameplate in a prominent position, indicating the model and the rated values. The rated values refer to the parameters specified by the manufacturer according to the national standards and for normal operation of the transformer. Operating within the rated values ensures that the transformer can operate reliably and perform well within the design lifespan. The model of a transformer is composed of Chinese pinyin letters and numbers arranged in a specific order. The letters represent the basic structural features of the transformer, and the numbers represent the rated capacity and rated voltage of the high voltage side. The rated values of power transformers include rated capacity, rated voltage, rated current, etc. Rated capacity refers to the guaranteed output apparent power of the transformer under rated voltage, rated frequency, and rated operating conditions. For three-phase transformers, the rated capacity refers to the total capacity of the three phases. The rated voltage U1N is specified according to the insulation strength and allowable heating conditions of the transformer. It is the voltage at which the primary winding operates normally. The rated voltage U2N of the secondary winding is the no-load voltage at the secondary winding terminals. When the primary winding is supplied with rated voltage and the tap changer is set to the rated tap position. For three-phase power transformers, the rated voltage value refers to the line voltage value. The rated current of the primary winding is I1N, and the rated current of the secondary winding is I2N. For three-phase power transformers, number of phases, impedance voltage refers to the line current value. It can be calculated from the rated capacity and rated voltage of the transformer as shown in the formula in the courseware. In addition, the nameplate of the transformer also indicates the rated frequency F, connection group symbol, cooling method, and operating conditions. Next, there are two after-class exercises. Think about the following. Based on the number of windings on each phase of the iron core, transformers can be classified into auto transformers, double winding transformers, and three winding transformers. The rated capacity of a transformer refers to the power, which is apparent power. Today, we discussed the classification of transformers and nameplate data. That's all for this lesson. Thank you for watching.